Welcome to The Explainer. I'm so excited you're here. We've got a massive goal today. We're unpacking exactly how we use social science, geography, and history to make sense of this beautifully chaotic, complex world of ours. Seriously, there's a lot to cover, so let's dive right in and start unraveling the hidden systems that govern our everyday lives.
We really live in an age of extreme paradoxes. On one hand, our globe is just pulsing with dazzling technological progress, global trade, and instant communication. But right alongside all that brilliance, we're seeing armed conflicts, rising social tensions, and some pretty severe environmental stress. So it brings up the fundamental question of our time. How do we actually learn to live in peace, harmony, and sustainability? Well, before we can even try to solve humanity's problems, we have to deeply understand how human societies actually work.
Here's our roadmap for today. We'll start with the 21st century challenge, then look at the social science toolkit, the mapmaker's dilemma, mastering the global grid, the mechanics of time, and finally, wrap it up with the explorer's synthesis.
Section 1. The 21st Century Challenge. Understanding Our World.
Think about the natural sciences for a second. Physics, chemistry, they're driven by rigid mathematical equations, governed by universal laws with set procedures and fixed results. It's like tightly interlocked gears. But social science, that's entirely different. It's more like a glowing web of interconnected nodes. It absolutely uses scientific methods, for sure, but it embraces the beautiful, messy unpredictability of diverse human societies. Social science isn't just a bunch of academic theories. It's literally the essential toolkit we need to navigate the dynamic web of human complexity.
Section 2. The social science toolkit, the 5 lenses. So, how do we break down this massive toolkit? We use 5 distinct lenses. Think of these as the core pillars guiding absolutely everything we do. First up, we have space, or geography, how the literal land shapes the people. Second is time, which is our history, how the past unlocks our present. Third is identity, our culture and the principles that guide us. Fourth is power, politics basically, and how we govern ourselves. And finally, survival, which comes down to economics, how we manage our resources to stay alive. Seriously, pretty much everything happening in your life right now can be explained through at least one of these 5 lenses.
For today's explainer, we're going to zoom in specifically on that very first pillar, space. Geography is so much more than just a little blue dot locating you on your phone's map app. It's the study of how vast oceans, towering mountains, and winding rivers literally dictate how and where entire civilizations develop. It's absolutely no coincidence that almost every major historical metropolis was built right next to a navigable river, right? So we've got to begin our physical navigation of the Earth right here, right on the surface.
Section 3. The Mapmaker's Dilemma. 3D reality versus 2D paper.
Now this brings us to a massive historical problem. How exactly do you take a huge 3-dimensional world and fit it onto a small, flat piece of paper? Well, you kind of have to make a choice. A 3D globe gives you incredibly high accuracy, obviously, since it's a true sphere. But the portability is just terrible. You can't exactly stuff a globe into your back pocket. A 2D map, on the other hand, is perfectly portable. You fold it up, stick it in a glove box, print it in an atlas. The trade-off? The accuracy is compromised. You're always going to get some inherent distortion around the edges.
To really wrap your head around why this distortion is totally unavoidable, just imagine the Earth is an orange. If you peel that orange and then try to flatten the peel completely against a table, what happens? It either tears or it stretches. It's just physically impossible to represent a sphere perfectly on a flat sheet of paper without tearing or stretching the reality of the surface.
So, to work around this tearing and stretching, mapmakers invented a brilliant universal language, the anatomy of maps. First, they introduced distance, dictated by a strict scale, so you always know exactly how far away things are. Then they brought in direction, using a compass rose to lock in north, south, east, and west. And finally, they used symbols, basically standard icons that replace complex drawings. This saves a ton of space and ensures absolute clarity for anyone, anywhere in the world trying to read it.
Section 4. Mastering the global grid. Coordinates.
Okay, think of the Earth's coordinate system like a giant chessboard, wrapping all the way around the planet. To locate a specific place, maps rely on intersecting lines. You know how the columns and rows on a chessboard give every single square a unique, precise identity, like E4? Well, the 2D grid we project over our 3D globe does the exact same thing for every single inch of our planet.
Let's build this master grid together. First up, latitudes. You can think of these as rungs on a ladder running east to west around the Earth, with the equator acting as our 0-degree reference point. They divide us into the northern and southern hemispheres, and crucially, they determine our climate zones. Then, cutting right across them, we have longitudes. These run north to south, pole to pole, starting at the prime meridian. They slice the Earth into eastern and western hemispheres, but their main function is actually completely different. They determine our global time zone.
Now, to actually measure longitude, humanity needed a starting point, right? An absolute zero line. Today, the world universally uses the Greenwich Meridian, which was established in London back in 1884. But here is a really fascinating historical fact. Centuries before Europe set the Greenwich line, Indian astronomers like Varahmihira were already using a prime meridian called the Madhya Rekha, which translates to middle line. This ancient absolute zero passed right through the astronomical center of Ujjayini, and it allowed them to calculate incredibly complex planetary coordinates way before the modern era.
Section 5. The Mechanics of Time. Geography as a Clock.
The absolutely crucial point here is that measuring longitude is essentially the exact same thing as measuring time, and the math behind it is beautifully simple. The Earth is a sphere, which means a full rotation is 360 degrees, and as we know, it takes the Earth 24 hours to complete that rotation. So if you just divide 360 degrees by 24 hours, you get exactly 15 degrees per hour.
As our planet spins from west to east, the sun illuminates different parts of the globe in chunks of 15 degrees at a time. And this gives us our golden rule of geographical time travel. For every 15 degrees you move east, you gain an hour. For every 15 degrees you move west, you lose an hour. When we apply that rule to the world map, we run into some truly fascinating geographical anomalies. To keep things unified, countries will establish a standard time based on a central longitude. India, for example, operates entirely on one single standard time. But then consider massive geographies like Russia. It is so incredibly wide that it spans across 11 distinct time zones. If you were taking a train from coast to coast in Russia, you'd have to physically adjust your watch 10 different times. Talk about the ultimate recipe for jet lag without ever leaving the ground, right? And this finally brings us to the edge of the grid, the International Dateline. Located directly opposite the prime meridian at roughly 180 degrees longitude, this invisible line zigzagging over the Pacific Ocean is the literal seam of the world's clock. Crossing it dictates a full 24-hour shift. Stepping across it effectively allows a traveler to step directly into tomorrow or jump right back into yesterday. It is quite literally geography functioning as a time machine. Section 6. The Explorer's Synthesis. Putting it all together. At the end of the day, we don't just overlay these grids onto our planet to plan our road trips. We do it to survive. Geography determines where we can build, history tells us how we got there, and economics dictates whether we'll actually thrive once we arrive. This invisible web of rules completely defines our physical reality, which proves exactly why that social science toolkit we talked about earlier is so incredibly important.
I want to leave you today with some profound ancient wisdom from the Indian mathematician and astronomer Aryabhata, written way back around the year 500 CE. He wrote, "The globe of the earth stands in space. It is surrounded by all creatures, terrestrial as well as aquatic." Humanity has been on this incredibly long, beautiful quest to map our spherical home and truly understand the complex web of life living on it. Think about it. If just drawing a few invisible lines on a map creates such a complex web of time and survival, imagine what happens when we throw politics, economics, and culture into the mix. It's kind of mind-blowing. Thank you so much for joining me for this explainer, and as always, keep questioning the systems around you.